So now that we've kind of talked about the structure and functionality of the common module in our QuoteServices app case study, let's take a look at implementations of the various classes. So things like the quotes class, the base application class, and the array utils class. And as usual, you can find all of those implementations here at this link in my GitHub repository, my live lessons GitHub repository. So here we are in my live lessons GitHub repository. This is for the EX3 project that's part of the WebFlux folder in my live lessons GitHub repository. And we're going to take a look at some of the common classes. So let's first take a look at base application. We had kind of talked about this before, so I won't spend a lot of time on stuff we covered in the earlier part of this lesson. You can see here's the static run method that takes a class and extracts the name, and then uses that name to identify the name of the application that Spring is going to be aware of. But let's take a look at one other interesting thing here. You can see down below in later parts of this class, we have a couple of beans. And the first bean we define is going to define the async task executor. And this basically tells Spring to use Java virtual threads to handle each of the incoming requests. So whenever a client makes a request, that comes in here, and that's going to be handled by the virtual thread mechanism. And down here, we also tell it to go down inside the Tomcat web server and also set that up in the inner portions to use virtual threads. So we're basically setting virtual threads for all incoming requests. And that's nice because that's a newer feature that came in Java 19 and beyond, and it gives us ideally some better scalability than using the servlet thread pool, which is what was used previously in Spring and is also what is used if you don't go to any extra trouble like we're doing here to set the beans as we saw. Let's take a look at the quote class. We've looked at this before too, so I'm not going to spend much time on this. Also, just says that class quote implements the comparable interface. It's an entity. It's a table. We got these annotations. You can see up here that we import the Jakarta persistence ID annotation here, and then we go ahead and provide this one with the full path because otherwise there'd be a conflict. So we have an integer ID. We have a quote that's the string. We have a constructor, and then we have a get quote method, and that's used for some of the calls later in order to be able to get the string value of a quote. And then down here, we've got various methods that do comparisons for the purposes of sorting. We also have this equals method that uses the cool pattern matching instance of operator that we talked about. This came along in more recent versions of Java. And then finally, we have the hash code. So that's all pretty much what we looked at before. Let's take a closer look, however, at array utils. This is a very useful utility class that we need when we're dealing with R2DBC and custom queries. Again, for some reason that escapes me, they don't build this into the R2DBC framework, so you have to write your own little converter class. This is what we have. We have this class called array utils, and we have a method here called object to list. You give it an object, and if that object is an array, then we go ahead and we take the elements in the array and we turn it into a stream of objects. We then convert each object to its string representation, and then we take each string and we call this method called convert to number. And what convert to number does, as you can see here, is it goes ahead and takes a look at the class that we passed in and the string that we passed in. The string contains the information that came out of that object. And depending on what type of class it is, if it's an integer, then we go ahead and we use the integer value of factor method to turn the string into an integer. And then we cast that back to the appropriate class, in this case, an integer class. Notice that all these classes have to be extensions of number. So we can do integer, long, float, double, short, byte, and so on and so forth. And this uses the new style switch statement to do all that processing in a more secure and robust way. So that's what convert to number does. We convert each of these strings into the corresponding number. We filter out anything that was null if it failed for whatever reason. Then we go ahead and cast it back to the type that we're expecting to return from this particular class. And we end up making a list of objects of whatever we've cast to. So you basically converting this object array into a list of the corresponding concrete types. Then we also have another method here called object to number, which is what you're actually going to use in your programming assignment. And this is kind of the same idea, except rather than having an array, we just have a single object. So it takes that single object. If the object's null, we bail out. Otherwise, we convert the object into a stream with one element. We convert that into a string. We convert that string into a number using the convert to number method we just looked at a moment ago. Then we go ahead and filter out anything that's null. We cast this back to the corresponding class that we want. And if all goes well, we return the results. And so that's how we're going to end up getting the values back here as a number. So these are very helpful little classes that are shared and reused. We've got some other stuff that's shared and reused too. We've got the list of constants or a file full of constants, like the HTTP request endpoints, which we use to make sure the client and the server are all synced up with each other. We also have different microservices. They have the same different endpoint names, and we use strings again. We use symbolic constants as opposed to string literals, just to avoid surprises if we maintain and update the code in some way. And there's a few other things here that we've got that are useful, but things like the Zippy microservice and the Handey microservice and so on and so forth. And then the last thing we'll look at in common is just something called the YAML property source factory. For whatever reason, in modern Spring, for some reason, they don't have YAML built in. So if you want to use a YAML file, and we use a bunch of YAML files later to configure things, you need to have a YAML property source factory. And you have to have this file somewhere so it can figure out how to parse the YAML files and make them into the corresponding properties. So that's a walkthrough of the common classes that we use through all the other parts of the program, in particular the Handey microservice, the Zippy microservice, as well as the client to test drive this whole thing.